In this chapter, we're going to attempt to give this crude, unpolished frying pan a little bit of pizzazz by making some materials for it and setting up a decent render. Now, rendering is a whole topic in and of itself, and there are literally people who have full-time jobs devoted to software rendering because there is so much behind it. In the Himalayas, there is literally a whole tribe of indigenous people who dedicate their lives to rendering. And a good render with nice reflection and nice soft lighting and bounce lighting and all these kinds of things that we see in the real world can make all the difference in the world. So to render, we simply click on this teapot all the way in the top right corner here. We can also press F9 as a shortcut. When you click it, the render buffer pops up and renders us our image. And as you can see, the rendered image looks a heck of a lot nicer than our real-time viewport preview. Now this frying pan rendered extremely quickly, but that's just because we don't really have very much going on. We have the default viewport lights, we have very, very basic materials here, but the more stuff you have going on, the more polygons you have, the more lights you have, the more advanced kind of shadow algorithms you're using, the more reflections and indirect illumination you have, the longer it will take to render, and it can get to a point where it takes quite long to render. But that's the cool part about software rendering. We can do all the crazy stuff we want, and the computer will just take its sweet time and figure it all out, and then we'll have a nice 2D image afterward. Unlike real-time rendering, where everything has to happen, well, in real time, like this viewport is a real-time render. This is what we're dealing with in a game engine. And real-time rendering has come a long way, but it is still nowhere near software rendering. So even though this is a school for video game artists, and all the techniques we teach at this school are mostly for video game artists, I think it's still important to know a tiny bit about software rendering, just in case you're working on something and maybe you haven't moved it into a game engine yet, and you just kind of want to get a preview of what it'll look like, and you want something that looks a little bit nicer than the max viewport, or you're making a portfolio piece that is game spec in terms of polygons and textures and everything, but you want to make it look as nice as possible, so you software render it. Okay, let's close out of that. I'm going to close out of our material editor for now also. By default, whenever we press this render button, it will render whatever viewport we have active. So if we go into, for instance, our orthographic view here, and then press the render button, it'll actually render from that view. So if we wanted to compose a shot, like move our perspective view to a nice angle and settle on that angle, and we want that to be our angle from then on, we can actually make a camera in our scene. And to do that, we can either add one in the Create tab and then go to Cameras here. And we have two different kinds of cameras. Or the way I like to do it is I'd like to just roughly put my perspective view where I want my camera, and then I press Control-C. And it looks like nothing happened, but if you look in one of the other views, you'll notice that it actually added a camera. So if you want your perspective view back, you can simply press P, and that'll get you back to perspective view, and then you're free to rotate about again. If you want to look through the lens of your camera again, you can press C. So what I like to do generally is sacrifice one of my orthographic views for a camera view. I just go to one of my orthographic views and press C, and then that'll be my camera view, and I like to keep my perspective view for actually working. And by the way, all of our views we can access by clicking and holding where it says Camera 01, or where it actually says the name of the view we are, and click on any of those. We don't have to use the hotkeys. Same thing with our wireframe and everything. When we're pressing F4, we can change that all here. Probably should have mentioned that earlier. So I'm going to change our camera view to realistic, since I don't really want our camera view to be wireframe. And then I can continue to refine the composition of our shot by making minor adjustments by moving our camera. You'll notice that we can't rotate our camera side to side. It's only rolling around. Well, that's because we have a target camera, which means the camera's pointing at a target. So if we wanted to rotate our camera, we could simply move that target, and our camera will always stay pointing at it. I find this camera easier to control. So that's the difference between these two types of cameras. A free camera has no target. It's just like an object you can rotate about. And a target camera, well, has a target. So we can put this target in a strategic place, like right by our pan, and then our camera will always be looking at our pan. And if we move our camera, you'll notice it'll stay looking at our pan. Okay, now I'm just going to make our camera 01 viewport active and take a render. Looks like garbage. Let's block in the material for our handle now. I'm just going to press M to bring up my material editor again and select our handle and our two little rivets with Control, and just click on a new material ball and say Assign Material to Selection. Now our handle color will be brighter than our pan color, and I'm going to set its shader type to metal and give it a little specular. Now let's take a render and see what it looks like. Be sure to select your camera viewport before you hit render, otherwise it'll actually render your perspective viewport. Still looks like garbage. Well, the main reason it looks like garbage is because we have default viewport lighting. So by default, Max just kind of places, I think it's 2 lights somewhere relative to your current camera position, and we can't see them in the viewport, but they're there, because if they weren't there, then our render would just be black. We also wouldn't really have any means of shading in the viewport, so our geometry wouldn't have any form to it. So let's make our own lighting. But first let's get rid of our jet black background, because a jet black background is not a very good background for a black pan. Now we could go to rendering and click on environment and change our background color to something other than black, but let's do one better. Let's actually make a floor plane to go under this pan so that it casts a nice shadow onto that floor plane. So I'm going to kind of model a little studio setup for this pan to be. And this is what I do for like an Apple commercial looking background, I guess. I simply make a box. I make sure to make it a square, so I'm just going to put in its parameters 100 by 100 by 100. Doesn't really matter the dimensions, we're going to end up scaling it anyway. And then I add a turbo smooth modifier to the box. This looks really abstract, but you'll see where I'm going here in a second. I'm going to turn up its iterations so it's nice and smooth. Maybe I'll turn them up once more so we get a real smooth thing. Then I'm just going to convert the whole thing to an editable poly. I'm going to press F4 so I can see my wireframe. Go into one of my orthographic viewports, go into polygon mode, and just select the top polygons and delete them. Then I'm going to grab this edge, press Alt-L to get its loop selection, and just drag this last row up. I know this really is not making a lot of sense right now, but you'll see in 1 second. Okay, now I'm just going to put this guy in the middle of the scene. I can either kind of move it to the middle of the scene, or I can just here, when I'm in move mode, it'll show me the coordinates for this object. I can just put in 0 for all of these fields, and that'll move it right to the origin of the scene. Now I'm just going to go into scale mode and scale it up nice and big, and scale it up in Z. And then just move it right under my pan. Make it a little bigger here. Okay. Now I'm going to give it a nice, almost white material with no specular. Assign to selected. Cool. Now you'll notice that our geometry is now see-through when we added the material. Well, that's because we're looking into the back side of our faces. To remedy this, we can either check two-sided or go into polygon mode and press Ctrl-A to select all of our polygons, and then just press flip. And that'll actually flip the directions of the polygons, because since we created this from a box, by default the direction of all the faces are obviously facing outward, not inward. The flip thing is actually going to be the better solution, because if we had two-sided checked, then depending on where our lights are in our scene, the high walls of our big dome might actually be casting shadows into itself. If that doesn't make any sense, just try checking two-sided and you'll probably see what I mean. Let's start placing some lights and get all artsy about it. So in the Create tab, we have a category called Lights. In this tutorial, we're going to be using the standard lights, so just go ahead and change your drop down to standard. And I'm going to place a couple omni lights here. An omni light is just a point that radiates light in all directions, or omnidirectionally. It's also known as a point light. And you'll notice the second we place a light in our scene, it gets rid of the default lighting and switches over to the light we've placed. Okay, and I'm just going to move this light. Maybe place it here. And then I'm just going to shift drag off another light. And then maybe make it a little lower and have it come in from the other side. By the way, only this bottom right view is set to constantly update. You'll notice that as I move my point light here, the bottom right viewport's specular highlight is updating accordingly. However, the bottom left one's is not. So perhaps it might be best to set your bottom right viewport to be your camera and your bottom left viewport to be your perspective. That might be a better situation, because now when we move our lights around, we can actually see them update from our camera's view, which is the most important view to make artistic decisions from. Let's dive into some of the settings for these lights. So I'm going to start with our higher light, and this light is going to be our key light, as a photographer would call it. So we have all kinds of parameters here in the Modify tab. We're going to barely scratch the surface for them. Under Intensity, Color, Attenuation, we have very basic ones. The multiplier is simply how powerful the light is or how bright it is. And this color swatch is the actual color of the light that is emitting. Now we want our key light to be casting shadows. So the way we can do that is simply by enabling shadows, because by default, if we take a render of this, our light isn't casting any shadows. So we want it to cast shadows. Now if we render, we see that it is casting shadows, but really awful looking shadows. I very rarely use shadow map because the shadows it produces are generally pretty awful. For soft shadows, I usually go with area shadows. That'll give me the parameters I need to make some nice, soft, doughy shadows. And for sharp shadows, like a bright sunny day or something, I usually use ray traced shadows. So since I'm going for kind of a studio looking setup here, I'm going to use area shadows. And once we click area shadows, all the way at the bottom here, we have area shadows, and we get some parameters here. Now if we want like a soft light, we could turn this sample spread up. Let's try like 16. Now we have way too much light in our scene in general, and that's because this secondary light I kind of want to be our fill light. So it's not going to be nearly as bright as our key light. So up in intensity, we're going to lower this to maybe like, I don't know, 0.3, something like that. Let's take a render. That's better. Still pretty horrible though. Now, remember when I said before that the standard ambient light in Max is pretty crappy looking and that we have better methods of doing ambient light? Well, I'm about to show you a really good method of doing ambient light, and that's to use a skylight. So we simply create a skylight, and the skylight actually doesn't matter where you place the light. It's just kind of going to hit our entire scene with some ambient light, except it's going to be really nice, soft ambient light. But to make it actually work, we need to go into our render settings. So we can click on render setup here, and we need to go to advanced lighting and be sure that light tracer is active, because by default it's off, and then the skylight won't work at all. So now let's take a render. By the way, the lighting model that our skylight is using is known as ambient occlusion. You'll notice that our render is going a lot slower, but our pan does look a lot better. I'm thinking our scene has too much light still. I'm thinking our pan is a little bit too bright and should be darkened, and I think our specular highlights need to be tightened a little. So I'm going to do all those things. I'm going to select my key light, turn it down to 0.7, select my fill light, maybe turn it down to 0.2, and then select my skylight and turn that down to, I don't know, 0.7. I'm going to jump into my material, make my pan a tiny bit blacker, tighten my specular highlight by increasing the glossiness. Ooh, maybe I increased it too much. And I'm going to tighten my glossiness is really low on my handle. So I'll increase that too. Let's see what that looks like. Well, I think that's a step in the right direction. Now our composition is a bit wonky. We can actually get a better indication of what our composition actually looks like by holding click on camera 1 in our viewport here and then enabling show safe frames. Now if we go into render settings, under common we have all of these common settings. I'm just going to change our resolution to 1280 by 720 because that's the resolution that this tutorial is being recorded at, and I want to make a nice render for you guys and display it on your screens all beautiful and such. I want to tighten our frame around the pan. We could move the camera closer, but we could also select the camera, and under its parameters we could change its field of view. Maybe 50 is good. And I'm going to move its target a touch. Since we increased the resolution, it's going to take a lot longer to render. Our render is almost looking spiffy. There are still a couple of ways though that I think we can improve it. Something that has been bugging me is how low poly this pan is. Now, in a game, this pan is already considered high poly, but considering we're taking a render of it, like right front and center, and it's the subject of our shot, I think that we can afford some more polygons. So, I'm just going to select our pan and add a turbo smooth to it. Now that's going to make our pan smoother. It's also going to round out the lip of our pan, which we don't necessarily want. So, to sharpen it up again, we could dive down into sub-object mode of our editable poly. I'm going to press F4 so that we can see our wireframe. I'm going to select an edge, press Alt-R to get a ring selection, and then go for a connect here. I'm going to use the slide parameter to slide this edge up close to the lip of our pan, and I'm going to do the same thing on the inside. I'm going to need to slide it in the other direction though. Now I'm going to do the same thing on the actual lip. And I'm going to turn the slide to 0. Alright. Oops. So I accidentally exited out. You need to click the check to make sure to confirm it. Now if I hop back up to the turbo smooth, you'll notice that our lip now has some good definition. Let's take a render. That's looking nicer. I can see some really faint lighting artifacts here at the base, and that's because of this giant polygon here in the middle. If we dive down into sub-object mode and look at that polygon, we can see it's really big and it's an n-gon. Now, n-gons are polygons that have more than 4 sides. In the end, Max will always cut this entire mesh into a bunch of triangles, no matter what you do. Even quads, secretly, behind the scenes, Max is actually thinking about them as triangles. Same story for this giant n-gon here. And if we have an n-gon like this, Max pretty much divides this up into whatever way it wants. I have a sneaking suspicion that if we did a little inset here, it would get rid of those artifacts. Let's take a look. Looks like that did the trick. Okay, lastly, let's give our pan a little bit of texture. Oops, I accidentally moved my camera. I'm just going to Control Z that. And I'm going to hide my wireframe. I'm going to open up my material editor, and let's see if we can't use one of these procedural inputs to generate us a little bit of texture for this. I'm going to go for that spackly looking stuff that you often see on pans. I suppose is the type of metal they're made out of or something. So I'm just going to go ahead and check diffuse color, because instead of a solid color, we're actually going to be having a map for this. So I'm going to click on none, and our little material map browser will pop up. And like I said, usually we're going to be clicking on bitmap to load ourselves an image which we created in Photoshop. But in this case, I'm going to go for this noise generator here. Okay, now this noise generator will generate us noise, and hopefully we can make this noise look like that little spackly stuff. We have a couple different types of noise. Just from experience, I think that turbulence is going to get us the closest. By default here, it's going to put white for its color too. Well, we certainly don't want white because the spackles aren't white. They're probably just like a lighter shade of black. Let's see what that looks like. Now, our noise is way huge. We want the noise to be like tiling 500 times this frequency or something like that. So I'm just going to decrease our size here, something maybe like 1. Let's try that out. Give it another render. Our spackles are still too large, so cancel out of that. I also think that the delta between our two colors is a little too extreme, so I'm going to make them a little closer. Maybe let's do like, I don't know, 0.3 or something. Now here's a trick if you're rendering a lot and you're really like working on something and tweaking something. You can just go into your render setup and just lock the pixel aspect ratio and then change this number to like, I don't know, 500. And then it'll be rendering a much lower resolution, so your renders will go a lot faster. And then once you're done making your tweaks, you can bump it back up to full resolution. I don't really have a problem with it though, so I'm going to leave it at 1280. I think that's going to do it for me. Something I want to mention with this material editor is that similar to our editable poly and how it has a hierarchy, so does our material editor. So you'll notice that when we're looking at this first material, the material that goes to our pan, we can't see our basic parameters like spec and stuff anymore. All we see is this procedural noise generator that we've created. To get back to the parent parameters of the material, you're going to need to click on this little Go to Parent button, and that will actually put us back up at the top of the material. See, if you click on Map, you'll dive down into the ranks of this material. And you can see in the drop-down menu kind of the hierarchy of things. However, when you're at the top level, you can't see levels below for some dumb reason. The last thing is I'm going to tweak my composition just a little bit more. I'm going to select my camera. I'm going to go into the Modify tab and tighten up its field of view a tiny. Maybe something like that. And I'm going to once again move its target a little. I think that'll be better framing. And here is the final render. Now, I know that was a ton of stuff, and over the course of the video I hit a million buttons, but like anything, if you do it a few times, it starts to get easy. This is a simple render, and if we really wanted to make this metal look like metal, it would definitely need a lot more detail in the model, and most importantly, some kind of world or environment reflecting in the surface. But this is just to get your feet wet. I encourage you guys to try all kinds of different stuff. Now this stuff may seem pretty heavy for the third chapter of an Intro to Modeling series, and it is. You may have to rewatch parts a few times for it all to click. But I feel it's important to show you guys a way of presenting your models with nice renders early on, because seeing your stuff with nice lighting and having a nice final product will inspire you guys. Even a box sitting on a plane looks pretty with ambient occlusion, a cast shadow, and a light or two.